Well, the Siemens-Mentor merger answered the need for a very critical capability in the industry, that is the evolution of integrated circuit design to full system design. There may be other mergers that solve this problem, or maybe there will be partnerships, but I assure you that in the coming decade or so, this capability will be critical to achieve the kind of automation that will be needed for systems and also the growth in requirements for integrated circuit design. Moore's Law has provided a driving force for the industry for decades because we've been able to shrink the feature sizes and grow the wafer diameters at a predictable rate. That predictable rate will have to slow because Moore's Law is an exponential and no exponential goes on forever. But we are actively working on the rule set for 3 nanometers that Caliber will have to provide verification tools for, and there will be nodes beyond, although they probably won't involve the same rate of shrinking of feature sizes, but they will produce the reduced cost per transistor, reduced power, and new capabilities that the industry will require, and that will continue for many years to come. The electronic design automation industry is in a fascinating trend right now. The reason? The number of customers, the number of people who are doing integrated circuit design is growing at a very rapid rate. We have all the traditional designers, and of course the number of design starts continues to grow despite the challenges of advanced technology. But added to that base now are systems companies and a whole variety of information companies like Google and Facebook and Amazon who have become very active designers. They are buying EDA design tools, they are developing capabilities, and they, like the automotive supply chain and many other industries, are finding that integrated circuit differentiation is critical to their survival and growth and to taking advantage of the information generation and analysis wave that's going on today. 2017 was a very unique year because there was a shortage of memory capacity. And that shortage, particularly in dynamic RAMs, caused a growth of 50% in the revenue of semiconductor memory companies. That's not likely to be repeated, and in fact we will catch up with the capacity, and there will be a let-off in the memory revenue and growth, but logic was actually quite strong as well, growing in the 7 to 8% range, and that shows no sign of weakening. I'd expect in the future we will always have the volatility of memory supply and demand, but the baseline of logic is steady, it grows, and we're now in a wave of innovation for new processor architectures, for artificial intelligence, for machine learning, for other capabilities, and this is a healthy wave of growth that I expect to continue in the semiconductor industry for quite some time. Automotive has been a tremendous driving force, and I expect that to continue. Of course, Mentor Graphics became the EDA leader in automotive in the early 1990s with its cabling and wire harness products, which expanded to embedded software and IC design tools. Recent stimulus has come from more than 100 companies developing autonomous driving vehicles, more than 300 companies that have announced they'll introduce electric cars and light trucks. All of this grows the complexity, and it greatly increases the amount of verification required. And that is not just chip verification, it's system verification. And the processing for pattern recognition and visual image processing creates some of the greatest challenges the semiconductor industry has had, and it will require a partnership of electronic design automation working with the vehicle OEMs, the Tier 2 suppliers, and the semiconductor suppliers to solve these problems and to comprehend and take advantage of this major transition in the automotive industry, which will benefit everyone. Israel's in a unique position because of the tremendous level of skill that exists in critical technologies like digital signal processing, like artificial intelligence, machine learning, pattern recognition, all a historical capability that's now being applied to the growth of whole new generations of processors and of the solution of problems, particularly in pattern recognition, but also advanced wireless communications, where Israel brings expertise, design experience, and capability that is probably unique in the world, and where, although there are not major automotive manufacturers, there is major automotive expertise that will lead to innovative new semiconductor products as well as system designs. There will be many drivers for semiconductors. IoT is one of them because the world will need more points of collection of information to process, but particularly the big data processing that goes on in the data center has to be augmented with edge nodes. And those edge nodes will become more powerful. They'll do more of the processing. And there are systems like cars that cannot depend upon internet connectivity and will build more and more intelligence into their electronics. So I think, in a way, IoT becomes the enabler for a whole new wave of semiconductor design that involves multiple technologies, either on the same chip or at least in the same package, including RF, digital, analog, MEMS, and other technologies. And Israel is a leader in innovation in putting these technologies together to create viable, low-cost system solutions.